The Earth is a place of breathtaking beauty, a planet teeming with life and wonder. From lush rainforests that teem with vibrant flora and fauna, to arid deserts that stretch endlessly under the scorching sun, life thrives in a delicate balance, each ecosystem playing a crucial role in the web of life. But our planet also harbors forces of incredible power, forces that can be both awe-inspiring and terrifying. These forces can reshape landscapes, alter ecosystems, and unleash chaos in an instant, reminding us of nature's raw power. Among the most awe-inspiring and terrifying of these natural phenomena are cyclones, also known as hurricanes or typhoons, depending on their location. Imagine a wall of wind and water, hundreds of miles wide, bearing down on the coast with relentless force. The sky darkens, the air grows heavy with moisture, and an ominous roar signals the approaching storm, a harbinger of nature's fury. This is the raw power of a cyclone, a natural phenomenon that reminds us of the immense forces at play on our planet, forces that can both create and destroy. Cyclones are not merely destructive forces, they are also agents of change, reshaping the landscape and influencing the climate. They are vital parts of Earth's climate system, transporting heat away from the tropics and towards the poles, playing a crucial role in regulating global temperatures. Understanding these storms, their formation, and their impacts is crucial for our continued survival on this planet. Scientists and meteorologists work tirelessly to study and predict these powerful storms, aiming to mitigate their devastating effects. Join me as we delve into the heart of the cyclone, exploring its different forms, the science behind its fury, and the ways in which we can better prepare for and respond to these natural events. Together, we will uncover the mysteries of these powerful storms and learn how to coexist with nature's fury. What transforms a gentle sea breeze into a raging tempest? How does a serene oceanic landscape turn into a scene of chaos and destruction? The answer lies in the complex interplay of air, water, and Earth's rotation. These elements work together in a delicate balance, creating the conditions necessary for a cyclone to form. Cyclones, regardless of their type, all share a common origin, a difference in atmospheric pressure. This difference sets the stage for the dramatic weather events that follow. Picture the atmosphere as a giant, constantly moving fluid. It's a dynamic system, always in motion, always changing. When areas of low pressure develop, air rushes in from surrounding high-pressure zones to equalize the imbalance. This rush of air is driven by the need to restore equilibrium in the atmosphere. This movement of air is what we experience as wind. The stronger the pressure difference, the stronger the wind. Add in Earth's rotation, which causes the wind to curve, and you have the basic ingredients for a cyclone. This curving effect, known as the Coriolis effect, is crucial in the formation of these powerful storms. As warm, moist air over oceans rises into the low-pressure zone, it cools and condenses, forming clouds and releasing even more heat. This process is a key driver in the development of a cyclone. This cycle of rising air and condensation fuels the cyclone, causing it to spin faster and draw in even more moisture. The more moisture it draws in, the more powerful it becomes. Depending on the location and atmospheric conditions, this spinning vortex of wind and rain can develop into one of three main types of cyclones: tropical cyclones, extratropical cyclones, or mesocyclones. Each type has its own unique characteristics and impacts, but all are born from the same fundamental processes. Tropical cyclones, also known as hurricanes or typhoons depending on their location, are the undisputed kings of the cyclone world. These powerful storms are nature's most formidable forces, capable of reshaping coastlines and altering weather patterns over vast areas. Born over the warm, tropical oceans near the equator, these storms are fueled by the immense heat energy stored in these waters. The sun's relentless rays heat the ocean surface, creating the perfect breeding ground for these colossal storms. Imagine a vast cauldron of warm ocean water, heated to at least 80 degrees Fahrenheit or 27 degrees Celsius. This is the minimum temperature required to provide the necessary energy for cyclone formation. This warm water acts as fuel, providing the energy needed to kickstart the powerful upward movement of air that characterizes a tropical cyclone. As the water evaporates, it rises and cools, releasing latent heat that further powers the storm. As the warm, moist air rises and condenses, it forms towering thunderstorms that circle around a central point of low pressure, the eye of the storm. These thunderstorms are the building blocks of the cyclone, each one adding to the storm's intensity. This eye is often eerily calm, a place of clear skies and light winds, surrounded by a raging wall of intense thunderstorms known as the eye wall. The contrast between the tranquil eye and the violent eye wall is one of nature's most dramatic phenomena. Tropical cyclones can rage for days or even weeks, leaving a trail of destruction in their wake as they move across the ocean. Their powerful winds, heavy rains, and storm surges can cause catastrophic damage to coastal communities. Eventually, these mighty storms begin to weaken as they make landfall or move over cooler water. The loss of their warm water fuel source causes them to lose strength, but not before they have left an indelible mark on the landscape and the lives of those in their path. Section 4. Fury from the temperate zones, extratropical cyclones. While tropical cyclones may be the most intense, extratropical cyclones are the workhorses of the storm world, impacting a much larger portion of the globe. These storms form over land or water in the temperate latitudes, the regions between the tropics and the poles. Unlike their tropical cousins, extratropical cyclones are driven by the collision of contrasting air masses, warm, moist air from the south, and cold, dry air from the north. This clash of air masses creates a dynamic and often chaotic atmosphere, leading to the development of a low-pressure system. As the low-pressure system deepens, winds spiral inwards, drawing in moisture and fueling the storm. Extratropical cyclones are often associated with a wide range of weather phenomena, including heavy rain, snow, thunderstorms, and strong winds. They can be unpredictable and fast-moving, bringing significant impacts to both coastal and inland areas. Section 5. The whirlwinds within storms, understanding mesocyclones. While tropical and extratropical cyclones dominate the headlines, mesocyclones are the hidden powerhouses within many severe thunderstorms. These smaller but incredibly intense rotating updrafts of air are the breeding ground for tornadoes, some of the most destructive forces on Earth. Imagine a supercell thunderstorm, its massive structure towering high into the atmosphere. Within this storm, strong winds aloft can create an area of rotation, a spinning column of air several miles wide, the mesocyclone. As warm, moist air is drawn into the mesocyclone, it rises and spins faster, potentially extending down to the ground and forming a tornado. These violent, whirling vortices of wind can pack wind speeds of over 300 miles per hour, capable of leveling houses, uprooting trees, and flinging cars through the air like toys. Understanding the formation and behavior of mesocyclones is crucial for tornado prediction and warning systems, giving people precious time to seek shelter.